Hey, I'm Adam. Quick question. If I hand you a rope with 12 evenly spaced knots and say make a perfect right angle, could you do it? Tie the rope into a loop, count 3 knots on one side, 4 on the other, and the remaining 5 to close it. That 3 to 4 5 triangle gives you a right angle. It's a construction worker's trick today, yet it predates Pythagoras by more than 1,000 years. So, who actually invented Pythagoras' theorem? The short answer, no one and everyone. The long answer is a globe-spanning detective story. Let's walk the timeline, with a few reveals along the way. First stop, ancient Mesopotamia, around 1800 BCE. On a clay tablet known as Plimpton 322, scribes listed number triples like 3, 4, 5, 5 to 12, 13, numbers that fit the rule, A tutaputsu or B tutuo, and tutafexu or C tutu. They didn't write it in that formula, but they clearly understood the relationship well enough to generate whole families of right triangles. Jump west to the Nile. Egyptian rope stretchers, surveyor engineers, used a 12-knot rope to lay out fields and temples. The evidence from tomb drawings and problem texts suggests they knew the 3-4-5 triangle produces a right angle. Was it a full theorem? Maybe not in words, but it was absolutely a practice technique. Now the big reveal. In India, the Sulba Sutras, manuals for altar constructions, state a version of the theorem clearly. The Bodhayana Sulba Sutra, likely composed between 800 and 500 BCE, says, in effect, the diagonal of a rectangle produces the areas which the two sides produce separately. That's a 2 plus B2 amber C2 in verse. There are also geometric arguments, early proofs, showing how the areas fit. Head east to China. The Zhubi Suanjing, the 9 chapters on the mathematical art describe the Gugu rule, the Chinese name for the same relationship. By the 3rd century CE, the mathematician Liu Hui offers a dissection-style proof, rearranging squares to demonstrate the equality of areas on the triangle's sides. So where does Pythagoras enter? In Greece, around the 6th century BCE, Pythagoras and his followers were fascinated with numbers, geometry, and the idea that the world is built from mathematical harmony. Tradition credits Pythagoras with the first general proof that in any right triangle, the square on the hypotenuse equals the sum of the squares on the legs. Whether he personally did it is debated, no writings of his survive, but by 300 BCE Euclid nails it in the Elements, Book 1, Proposition 47. That proof is rigorous, elegant, and became the gold standard taught for 2 millennia. Here's a twist. The theorem didn't just have one proof, it has hundreds. Medieval Islamic mathematicians extended and generalized right triangle relationships. Indian mathematician Bhaskara in the 12th century famously sketched a one-word proof. Behold, a clean geometric rearrangement that lets your eyes do the logic. Even a US president got in on the fun. James A. Garfield published a proof using the area of a trapezoid in 1876. At this point you might ask, if so many cultures knew it, why call it the Pythagorean Theorem? Naming in math often follows the path of transmission into the Western canon. Euclid's rigorous synthesis, taught across Europe, cemented the label. But the idea is older and broader, more a shared human discovery than the work of one person. Why does it matter? Beyond school quizzes, it's the backbone of distance. Anytime I want the straight line distance, on a map in 3D graphics, in physics, the theorem steps in. Coordinate geometry? It turns slopes into distances. Navigation and surveying? It measures the world. Number theory? It sparks entire branches, Pythagorean triples for Matt's last theorem. So here's the big reveal behind the reveals. The invention of the Pythagorean theorem wasn't a single lightbulb moment. It was a chorus, tuned over centuries. Babylonian lists, Egyptian ropes, Indian versus Chinese dissections, Greek rigor, all converging on the same truth. If you ever draw a right angle or calculate a distance, you're tapping into that global conversation.